Okay, so I'm going to be going over Unit 3-6, Special Cases in Factoring. And there are three types of special cases in factoring that I'll be talking about, which is difference of two squares, perfect square trinomials, and greatest common factor, and then factoring. So we're going to start off with difference of two squares, and the rules for this is that it needs to be a term minus a term. Both terms need to be perfect squares, and the answer will look like the square root of the first term minus the square root of the second term, and then the other factor will be the square root of the first term plus the square root of the second term. And it can be flipped, like the square root of the first term plus the square root of the second term, and then the other factor be the square root of the first term minus the square root of the second term. You just need to have one of both. So our first example is 64x squared minus 4, and this fits the criteria for difference of two squares because both terms are a perfect square and it is a term minus a term. So how we're going to start off with this is we're going to take the square root of the first term, which is the square root of 64 would be 8, and then it has an x squared with it, so it would be 8x, and then the square root of the second term is 4, so the square root of 4 is 2. So for our first factor we can put minus 2, and then since you need to do one subtraction, one addition, it'll be 8x plus 2. And then those are our two factors, 8x minus 2 and 8x plus 2. Okay, for our second example, we have 81 a to the fourth power, b to the second power, minus c to the sixth power. And then this also fits the criteria because it is a term minus a term. Both terms are perfect squares. And so how we're going to start this is we're going to take the square root of the first term, which the square root of 81 is 9. Square root of a to the fourth power is a to the second power. Square root of b squared is just b. And then minus the square root of the second term, which is c to the third power. Then for our other factor, it's just the same thing, just with addition. So then that makes our two factors 9a squared b minus c to the third power, and 9a squared plus b. I'm sorry, I missed the little dash there. Okay, and then next we have our other type of special cases in factoring, which is perfect square trinomials. And the rules for this is that it must have three terms. The first and the third terms must be perfect squares, and the answer will be the square root of the first term plus or minus the square root of the third term. And then that'll be squared because they're both the same. And where this plus or minus comes from, that is determined from the middle term's sign. That is the sign in front of the b term. So this is sign in front of the b term. And then that gives us our factor, and it's squared because there's two factors. Okay, so our first example is x squared plus 20x plus 100. And this fits our criteria because it has three terms, and the first and the third terms are perfect squares. So what we can do is we can take the square root of the first term, which would be x, the sign of b, which is an addition sign, so that means we take x plus, because there's a plus in front of the 20x, and then we take the square root of the third term, and the square root of 100 is 10. So it's just x plus 10 squared, and that's our answer. Our second example is 49x squared minus 126x plus 81. This also fits the criteria for a perfect square trinomial because the first term is a perfect square and the third term is a perfect square. So we're going to start off with this by taking the square root of the first term, which the square root of 49 is 7, and it's 49x squared, so it would be 7x. And then we take, again, the sign of the b term, which this time it's a subtraction sign. So we're going to take 7x and we're going to put minus, and then we take the square root of the third term, and the square root of 81 equals 9. So it's going to be 7x minus 9, and those are both of our factors, that's why you have to put a squared sign. So 7x minus 9 squared is our factored. Those are our factors. The last special cases in factoring is finding the greatest common factor and then factoring normally. And the answer will be the greatest common factor times the factor times both factors. Or it could just be greatest common factor times the factor squared. Oops. Okay. Our first example is 5x squared minus 80, and you could just factor this normally, but both the terms have a factor that is similar, so we can take the greatest common factor out of it. So the greatest common factor out of 5x squared minus 80 is 5, so we can divide this whole thing by 5, and then you'll get x squared minus 16. So x squared minus 16 times 5. But you still have to factor this x squared minus 16, and luckily it is a special case in factoring, which is difference of two squares. So it'll just be 5 times the square root of the first term, which is just x, and then plus the square root of the second term. Square root of 16 is just 4, and then the other factor would be x minus 4, because that's the square root of the first term minus the square root of the second term. So our total factored form would be 5x plus 5 times x plus 4, and then the other factor would be x minus 4. And the 5, the greatest common factor that we took out, applies to both factors. The second example for doing greatest common factor and then factoring is 5x squared minus 40x plus 80. And we can take this and we can divide the whole thing by a factor of 5 again. So then dividing this by 5, we get x squared minus 8x plus 16. And this is all times 5. And then again, so our answer will have to start with the greatest common factor of 5 times our factors. Again, this is one of our special cases, so we can take x squared minus 8x plus 16 instead of factoring it normally and do a perfect square trinomial shortcut to this. So we're going to take the square root of the first term, which is just x squared, so that'll be x. The sine of the second term, so we're going to take the sine from minus 8x, and then just add the sine to our factor. And then the square root of the third term, which is 16, the square root of 16 is 4. So it'll be 5 times x minus 4 squared. And that's our factored form. Okay, that's all that there is. There's only those 3 types of special cases in factoring, which is difference of two squares, perfect square trinomials, and greatest common factor, and then factoring. And these are just easy shortcuts to get you to your answer faster when you need to factor a quadratic